All right, ladies and gentlemen, we are going to go through and do this homework. We're just going to do questions 2 through 5. I'm going to start with number 2. It says, if 75 grams of copper react with mercuric nitrate, how many grams of mercury form? So I'm going to start here. This is 75 grams, and we're looking for these many grams. So this is a gram to gram problem. And I'm going to call this A, and I'm going to call this B. And just as a reminder, just in case, grams to moles to moles to grams. That's how we do this. And when we go grams to moles, we use molar mass. And we use the mole ratio in between here. We always put moles of A on the bottom, moles of B on the top, because that's what we're looking for. And then we use molar mass between moles and grams. So that is our background. So I'm going to start, since it's gram to gram, I have a 1, 2, 3, 4 section truth table. I'm going to start it down here. The first thing that goes in is 75 grams of copper. Okay, so I have this 4 section truth table. Now, grams to moles, I need the molar mass of copper. So I take the periodic table. Copper has a molar mass of 63.55. So I put the actual mass on the bottom, 63.55 grams, in 1 mole of copper. Okay, and make sure you put the Cu, because in a minute we're going to be comparing. So our next step here is to compare what we have here between copper and mercury. Copper is A, so we're going to put moles of A on the bottom, so Cu, and this is B, what we're looking for, moles of Hg up here. Now we just look at our mole ratio. It's 1 to 1, so we have to write that down, 1 to 1. And now all of a sudden we're looking at mercury. And now in order to go to grams, we need to look up the molar mass of mercury. 1 mole of Hg, 1 mole of mercury, has a mass of, we go to mercury down here, 200.59 grams. And now that I have that, I can go through and I can do the math. I can take my calculator and write 75 divided by 63.55 times 200.59. And I end up with, and I'm just going to do 3 digits because there's 3 sig figs here. I'm going to say it's 237 grams Hg. Alright, so there we go. Alright, so now to the next question. Okay, the next question, number 3. What mass of sodium sulfate is produced when sulfuric acid reacts with 200 grams of sodium chloride? So the first things first is we're talking about what mass of this, we don't know, but we have 200 grams of sodium chloride. Okay? Now my issue is this balanced equation? Is this equation balanced? I have 2 sodiums here, but over here I only have 1. So I'm going to put a 2, and I'm going to have a 2 there. So now it is balanced. Now we look at our problem. It's grams to grams, okay? So if we go back up to here, grams to grams, that's 4 sections of a truth table. So I'm going to start with my 4 sections, and I'm going to start with what I've been given, 200 grams NaCl. Okay? So my next section, grams to moles, I need to use the molar mass of NaCl. And I'm going to put grams of NaCl on the bottom so they cancel out. I'm going to look it up on my periodic table. Na is 23, Cl is 35.45. So my molar mass is 58.45 grams in 1 mole NaCl. So now if we go back up here, we have moles of B over moles of A. Okay? So I think that A is what I've started with, so I'm going to put moles of NaCl on the bottom, and then I'm going to put moles of Na2SO4 on the top. Now we check out our ratio by looking at the balanced equation. What number's in front of Na2SO4? Nothing, so I'm going to put a 1. And what number's here? That's a 2, so I'm going to put a 2 right here. So now we have to the mole ratio part, so now we're up to here, and we need to go to grams. So I'm going to write 1 mole of Na2SO4. And how many grams is Na2SO4? So I get my periodic table and I get my calculator and I look. Na is 23 times 2 plus sodium's 32.07, excuse me, not sodium, sulfur, plus 16 times 4 for oxygen. I get 142.07. So now when we do the math to find our final answer, I'm going to move the calculator kind of down so you can see. Okay, the first thing we do is 200 divided by 58.45 divided by 2 times 142.07. I hit enter and I get 243 grams Na2SO4, sodium sulfate, right there. Alright, so now let's try the next one. The next one says how many moles are needed to form 3.5 times 10 to the third moles of Cl2. And they give us this reaction. We have to double check if it's balanced, and I see that this needs a 2 right here, okay, to get the oxygen. So that means this needs a 4, and this needs a 2 right here. So now we're all balanced up, and now I know that I have 3.5 times 10 to the third. I'm just going to take that out. I have this many moles, and it wants to know how many moles here. So this is a mole-to-mole problem. So if we go back up to the top, this should be just a 2 truth table problem. So I'm going to do it over here. I'm going to start with what I've been given, 3,500 moles Cl2. So mole-to-mole problem, now I'm going to put my moles of A, that's what I'm given. So I'm going to put moles of Cl2 right here, and moles of what I'm looking for, HCl up here. But I need the mole ratio, so I'm going to look for that. So HCl, the number in front of it is 4. The number in front of Cl2 is 2. And I'm going to do some crazy math. 4 divided by 2 is 2. I bet the answer is 7,000 moles HCl. And I'm going to double check that because you know what? Sometimes I'm not too confident. Times 4 divided by 2. Oh, I got it. That's the right answer. Alright, let's try the last one on this page. Okay, so it says how many grams of chlorine gas must be reacted with excess sodium iodide if 10 grams of sodium iodide or sodium chloride are needed. Okay, so that means I need 10 grams of this stuff. And they want to know X grams. So this is a grams to gram problem. So this is going to be a big problem. 4 truth tables or 4 sections. But before I can do it, I need to make sure this is balanced. And I see that there are 2 Cl's here, and I need to put a 2 there. And then I'm going to put a 2 there to balance it all up. So that's pretty sweet. So now it's time to actually do the math. So 4 truth tables, okay, or 4 sections. I'm going to do 10 grams NaCl. And we already found the molar mass of NaCl over here, so I'm going to put 58.45 grams NaCl in 1 mole NaCl. So now I've done grams to moles. So now it's time to do the mole ratio. So I'm going to put moles of A, which is NaCl, on the bottom. And what am I looking for? Oh, it's NaI. So I'm going to put moles of NaI on the top. And I'm going to look at the ratio. It's 2 to 2, so I'm going to put a 2, and I'm going to put a 2. Cool. So now we're here. Now we go from moles to grams. So I know 1 mole of NaI has a specific molar mass. I can take my periodic table. I look for I. I's molar mass in this case is 126.9, plus sodium is 23. So this comes up to 149.9 grams of NaI. And we're going to do this calculation. So 10 divided by 58.45 times 149.9, I end up with 25.6 grams NaI. Right there. Okay? So then we've gotten through that. Oh, maybe you can't see it. Let me move that over. Okay? So those are 4 problems from last night's homework. I think that watching this and going through it could help. I hope you have a good day. I'm not going to do the other ones. We'll talk about the other ones later in a different video if we do it. All right, bye.